Hello everyone, let's take a look at this LeetCode problem. Leftmost column with at least a 1. Okay, so it's a very interesting problem since this problem is an interactive problem. Okay, let's take a look at details. A row sorted binary matrix means that all elements are either 0 or 1. And each row of the matrix is sorted in non-descending order. For example, 0, 0, 1, 1, 0, 1. So 0 is at left and 1 is at right. And given a row sorted binary matrix, we need to return index of the leftmost column with a 1 in it. If such an index does not exist, we just return -1. For example, here, example 3, there is no 1, so we just return -1. Okay, we cannot access a binary matrix directly. We need to access the matrix using a binary matrix interface. So the first method is get, returns the element of the matrix at index row column. And second method is dimensions, returns dimensions of matrix as a list of 2 elements, rows and columns. Okay, and note submission makes more than 1,000 calls to get will be judged as wrong answer. So the constraint is, we know the row columns can be 100, so there are at most 10,000 elements. So we cannot call 10,000 times. We can at most call 1,000 times. So how do we solve this problem here? We know we cannot use a naive solution, otherwise we may call get 10,000 times. So we can use binary search here, assuming that this is one row. We have 7 zeros and 2 ones. So since it's sorted, so we can use binary search. First, we place I at the beginning and j at the end. And this is mid. Mid is 0, which means 1 is on the right, so we move I here. Okay, this is mid. It's also 0, we move I to right. And now I plus j divided by 2. Mid is here, same as I. And it's a 1. So we can move j to mid. And now I is same as j. So what's the while loop? Does not hold. We just break the while loop. And since it's a 1, so we can return this index. Okay. So this is the implementation. First, we get dimensions, and we initialize result to -1. And finally, we just return this result. Okay, as long as, okay, so we need to for loop each row. And for each row, we place left as 0 and right as column -1. And this is binary search. So as long as left is smaller than right, we continue the while loop. And we calculate the mid every time and check if the element is 0 or 1. If it's 0, we place left at mid plus 1. Otherwise, we update right as mid. Also note there's optimization here. Every time we don't need to always place right at column -1. Assuming that, for example, we already scanned 10 rows and result is 5. And next time we know result is already 5, so we just want to know if there is 1 at index before 5. So we can just initialize right as result -1. Then at last we check if it's a 1. If it's a 1, we try to update our result. Okay, that's it. So it's a medium problem and it's like high frequent. It's a frequent like interview problem like Facebook. Okay, that's it. See you next time.